Okay, so let's talk speed versus velocity. Speed is a scalar, whereas velocity is a vector. But they both describe the rate at which position changes. So what we mean by a rate is that it's something with respect to time. So we can think of velocity as how quickly your position is changing. Whereas speed, we can think of that as how quickly are you covering a particular distance. One example I want to give you is, let's say we have somebody who is running, and they are going to travel, let's say, at 6 meters per second for 5 seconds. Let's say the time has passed 5 seconds. Maybe that's too fast and they got to slow down, catch their breath. So now they're going to run at 5 meters per second. And let's say that's for another 5 seconds. So we would be here at perhaps 10 seconds. And perhaps the person's gone too far. So they're going to turn around for 1 second. So we're going to say that they are at rest. So they'll stay at rest for 1 second, which will put us at 11 seconds for their journey. And then maybe they head on back at 1 meter per second for, let's say, 4 seconds. So that'll put us at a nice 15 seconds. So if we want to find the average speed, some students may just add up all the different speeds, divide by the number of speeds, but this is not going to be the case because we spend the different times at each speed, or rather at each speed we're spending different times. Okay. To find the average speed of the person, some students may just add up the different speeds and divide by the total number of speeds, but that's not going to get us the right answer because we spend a different amount of time at each speed. So that's not going to work. What we need to do is take the total distance and divide by the total time. And if you notice here, I've rearranged the velocity equation to give us displacement, and this is going to be the same relationship for speed. Speed is going to be distance divided by time. So if we want a distance for one of these segments, we need to take the velocity times the time, or sorry, the speed times the time. So here it would be 6 times 5. That would be meters per second times second. Notice that will give us a distance. 5 meters per second all the way through 10 seconds, so 10 to 5 is 5 seconds. Plus, we're going to stay at 0 for 1 second. And then we're going to travel at 1 meter per second for 4 seconds. So all that over a total of 15 seconds, which will get us an average speed of 3.9 meters per second. The average velocity, since it's a vector, will not use the total distance, it'll use the total displacement over the total time. And that's going to give us the pretty much the same equation as earlier, but with one exception. Since we are concerned with direction, we need to show that that last part of the run is in a different direction. So I'm going to say that the left is negative, so that last segment is a negative 1 meter per second for 4 seconds. Still the same time. So we will get an average velocity of a positive 3.4 meters per second. And hopefully it's intuitive that the displacement and the velocity would have the same direction. But just in case, just to show you what's going on here, if this is our displacement, so we started here, or the stick figure started there and ended here, it has been displaced to the right. So the stick figure would need to maintain an average velocity of 3.4 meters per second to the right in order to reach that same spot at the same time as the original run. So this is what consistent velocity, so if we maintain this the whole time, would get us the same result.